Okay, so it looks like, I mean, I tried recording this before. We're going to see if this works again. Okay, very quickly. We are, ooh, let's, fireworks, maybe that's cool. Ooh, who doesn't love that? Okay, so we are going to go to Unit 2, we're going to go to Week 5, and we are going to go to Friday's folder. You got two things in here. Don't mind this GPS, GIS thing, it's already been done. You do have to turn in your bell ringers. You're going to include today's bell ringer. Today's bell ringer is right here, right? It is the different, like I have some incorrect statements. Earthquakes cause volcanoes to erupt. That's not true, right? I need you to make it true. So volcanoes cause earthquakes to erupt. And we could, make your own spin on it if you'd like to. But we have to make sure that things are logical, right? Something happens and then something happens to that. And we usually, like if you have a lot of that happening, right? This happens and then this happens and then this happens. Well, that means that that's a chain reaction, right? So you have a series of events that are happening back to back to back to each other, right? And that's what we call a chain reaction. A cause and then effect. And because of that effect, this affected it, and that affected it because of these things. So we call that a chain reaction. So once you get done doing this, let's go back to Friday's folder, and we're going to go to our bell ringers, and you're going to take a picture and make a submission here. Once you get done submitting, come back to me, okay? So once you got done, by this point you should have submitted your bell ringers, and now you are going to go to 2 days activity. And I'm going to upload the video and give you your exit ticket here in a minute. But for right now, watch this video. So this is the video you're currently watching. And what you're going to do is complete today's activity. So let's open this. And today's activity is what I call a chain reaction, right? We are seeing a cause and effect reaction for certain things to happen. We've been talking about physical features of the earth, right? Things that you can see, touch, and feel that come from the natural processes of Earth's surface within the hydrosphere, lithosphere, biosphere, and the atmosphere, right? So you're going to look at a couple of things. You're going to look at, first off, you're going to look at immediate causes. I'm looking rough, guys. It's late, by the way. It's like 11 o'clock. So immediate causes, long-term causes, right? Immediate effect, long-term effect. And this is all on the topic of glaciers. So let's go take a look. And I'm going to make this bigger so that way it's not so busy. That helps. Okay, so let's go take a look. So we're looking for causes and effects here. So to make this easier on me, what I'm going to do is first put my heavy laptop down, and then I'm going to use this text tool. And I always like to make a legend. A legend helps keep things straight for me. So let's put this right up here. Cause, effect. Pretty easy. And then what do I want to do? I want to mark it in two colors, red and blue. So all the causes will be in red. All the effects will be in blue, right? So let's take a look here. As I read through it, I might want to use my highlighter. So glaciers are not the only transport material as they move. Wow, this jumps right into it, right? But as I can see, glaciers not only transport material as they move, but they also sculpt and carve away the land beneath them. Okay, so first off, we have a cause and effect relationship here. First thing that we see as a cause is glaciers transport things as they move, but they also sculpt and carve away the land beneath them, right? So that is a big cause. As a glacier's weight combined with the gradual movement can drastically reshape the landscape over hundreds, even thousands of years. This sounds like another thing that has happened, right? Or will happen. So because it is going through and being so super heavy, right? It's so big. Insert your mama joke right here, because this glacier is huge and it is making this entire thing move. And because it's moving, it's causing the sculpting and changing the Earth's surface. That's why the Earth is actually the way it is. Especially like in the north, there's tons of like boulders that are just there because the ice had the boulder in it, and as it melted and receded away, right, it dropped that boulder off, and guess what? It's still there today. So we're looking at this. The ice erodes the land surface and carries the broken rocks and soil far away from its original places, resulting in some glacial landforms. Okay, this is definitely an effect, right? It's talking about resulting in some interesting glacial landforms. Fjords, glaciated valleys, and horns are all erosion types of landforms created when the glacier cuts away from the landscape. Now, the reason why I'm not underlining this, where's my pen? Yeah. The reason why I'm not underlining this stuff right here is mainly because this stuff right here is just kind of reiterating in more detail what I've already highlighted, right? So what's the point? Let's keep it rolling here. We're going to keep highlighting, okay? Fjords, glaciated valleys, blah, blah, blah. Other types of glacial landforms are created by features and sediments left behind after the glacier retreats. That sounds like a cause, right? Created by features and sediments left behind by the glacier retreats. When glaciers retreat, they often deposit large mounds of till, gravel, sock, whatever. Rocks, not sock. I saw small rocks and I put it together. It's made from rock soil in the ground beneath the glacier has moved. Okay. And as you can see, as I read through this, I'm just going to mark it. Materials, glaciers pick up and pushes as it moves from Muirian. God, I am struggling tonight, guys. You have got to bear with me because I am so tired. It has been an incredibly long day, and I'm just trying to make sure you can get this done. So bear with me as I struggle to read through a 7th grade level text. Okay, so material a glacier picks up or pushes. In other words, like the glacier has stuff in it. And sometimes when it and sometimes when ice freezes, it expands, right? Think about water. Water can get into any form that you put it in. But when you freeze it, the molecules build itself into a structure, and that structure sometimes comes up, builds out, and pushes things away. What it's talking about is as glaciers do that, the ice literally melts away from underneath the moraines so that they leave long, narrow ridges that show the glacier where the glacier used to be. This looks like an effect, right? Glaciers do not always leave these things behind because sometimes glaciers' own melt water washes the material away. In other words, sometimes we don't know where glaciers are because the water from the glacier actually erodes the place even more, causing it to be untraceable. Streams flowing through glaciers often carry some of the rock and soil debris out with them. These streams deposit debris as they flow. Hey, they deposit as they flow. This might be a cause here. Streams carry some of the rock and soil, and because of that, this happens here. Consequently, after many years, the mounds and soil gravel begin to form adjacent to the glacier called kames. Alright? Kames, lakes, form from a piece of glacier ice breaks off and becomes buried by the glacial tilled moraines deposit. In other words, God, this is so hard to just, like, all these words can be so new and hard to go through. But what we need to know is sometimes these glaciers will recede, right? And a piece of that glacier will break off because if you've ever seen ice isn't always that structurally sound, especially when it melts. And when it does that, it may inadvertently create its own like pond, lake, stream in some other area where the glacier has long been gone because this part broke away and stayed there. So that sounds like an effect. Kettle lakes form when the glacier ice break off and become buried by the glacial until the moraine deposits. Over time, the ice melts, causing, leaving, I think this is definitely a cause, leaving small depressions in the land filled with water, right? And glaciers leave behind anything you pick up along the way, and sometimes this includes huge rocks. Hey, they leave behind anything they pick up along the way, and sometimes includes huge rocks, called glacial erratics or erratic boulders. These rocks might be, this is just more detail, have literally moved them. Alright, now, here's what we got. We got 1, 2, I'm counting all my effects, 1, 2, 3, 4, 5 effects. So if I come up here, and I'm looking at effects, I've got 1, 2, 3, 4, 5, 6. Oh, I'm in the wrong spot because that was plate tectonics. 1, 2, 3, 4, 5, 6 effects. And I have 1, 2, 3, 4, 5 causes. So if I go back to my text, I should see 1, 2, 3, 4. Uh-oh, I'm missing one. I bet you this one right here this one is supposed to be an effect. So let's just change that. Okay. 1, 2, 3, 4, 5. Sounds about right. Okay, so now what we have to do is decide which ones are long-term and which ones are short-term, right? So we'll just do L and S to help determine this, and let's use, I don't know, the color black. Glaciers not only transport material as they move, but they also sculpt and carve away the land beneath them. That is a long term, right? Because that's going to affect the ground forever. A glacier's weight combined with this gradual movement can drastically reshape the earth. That's a long term effect. Resulting in some interesting glacial landforms. Okay, if it's reshaping the ground, that's definitely a long term. Created by features and sediments left behind after the glacier retreats. I think that would be long term. So we'll give it a L here. Give it its L. Deposit large mounds of till. I don't think that's going to be it. So let's give this one an S on this one. Narrow ridges that show where the glacier used to be. That seems like long, but I think we're going to go with a short term. Mainly because it can also be washed out. Streams flowing from the glaciers carry some of the rock and soil. I want to say short term. These streams deposit debris nearby. I think that's short. It breaks off. This might be long term here if I'm not mistaken. Leaving small depression in the land filled with water. That water could be there for a short while. That doesn't mean it's always going to be there. Leave behind anything they pick up along the way, and sometimes includes huge rocks. That's definitely going to be long term, right? So let's take a look here. I probably have more than what I'm supposed to. 1, 2, 3 long-term effects. I've got 1, 2, 3 short-term, long-term causes. We got 1, 2, we're counting the red here, looking like 2 short-term effects, and 1, 2, looking like 2 short-term, I think I did effects already. Yeah, 2 short-term effects and 2 short-term causes. So if I go up here, I want to just use this, and we have two long-term effects. We have three immediate causes, three immediate effects, and three long-term effects. So let's see. Definitely, let's take this one. Copy that. Let's paste it in the right spot. We said that was long term, and we said it was red, so that is a cause. Then I want to do the same thing here. The glacier's weight combined, so on and so forth. Oop. I know this is not entertaining whatsoever, but I am so drowsy. My goodness. I still have to brush my teeth and whatnot, guys. Let's see. We'll get this right here. Whew, that took me a hot second, but I knew you guys believe. Oh, my stuff is gone. Okay. Paste that. And then streams flowing from the glacier often carry rock from it. That's a short term. Let me see if I can find. Dude, get out of here. So we got some long-term short causes, some long-term effects. That's a long-term effect right there. Boop. And look at there. This is why I like doing it on the computer. These are immediate causes. I just put them in the wrong spot. So now all I have to do is drag and drop them. Okay. Immediate causes. So this is short term, right? So those are things like deposit large mounds, up till, gravel, whatever. We said streams flowing from glaciers are short term. If I can just pick up that part, I would be so happy, you guys. Oh my gosh, this is not riveting at all. But, you know, stick with me. Yeah. There we go. Whoop. Haha, you thought you could. You thought. Alright, so let's go ahead and put this up here. We got one more short-term effect floating out there. And I'm almost positive we don't have it. So we're going to have to think about it. Okay. Narrow ridges that show where life in Glacier used to be. That is a short-term effect. Okay, let's keep it rolling. And as you can see, I'm just kind of sorting out stuff. Leaving small depressions in the land. That's, I believe we settled that was a short-term solution. So we're going to grab that. You monkey's uncle. Alright, let's go ahead. Because that water's not going to be there for forever. That's my mindset here. So we're missing one short-term immediate effect, and I bet you I can go ahead and grab these other two long-term effects, right? So okay. Let's go take this back to the long term. Oop, not that one. Okay, we did pretty good. What we're missing is we are missing a immediate effect and we are missing an immediate cause. So there's some type of relationship that we just missed. Called glacial boundaries. These rocks might seem a little out of place, but it's true. No. Let's see. Feels like there's a gap right here. So as long as they live, narrow ridges that show the glacier used to be. Glaciers do not always leave these places because sometimes glaciers' own melt water washes away the material. Okay, maybe that's what we're looking for. So we're going to split this one. Sometimes, so this is the thing that's important about this is clearly like not always is it just a sentence. Sometimes it is like one sentence split up into two spots. So I'm going to go ahead and I think this was an effect, an immediate effect, right? Glacier's own melt water washes away the material. That's a short-term effect. What's the long term of not having that material? Well, let's see, where's it at? Narrow ridges that show where glaciers do not always leave moraines because, however, it's a weird wording. Behind, however, because sometimes, that's a lot. The glacier owns meltwater, washes it away. So we got one immediate effect. Is there another immediate cause here? Picks up and pushes and moves moraines along the surface and sides of the glacier. I think this is what we're talking about for a cause. Because what happens here is material a glacier picks up, so it's talking about the stuff inside of it, is causing it to move faster and melt faster inside surfaces. Because it has stuff, it doesn't matter why it does it, it matters as to what is supposed to be on here, right? Like exactly when we talk about material a glacier picks up or pushes as it moves from moraines along with the surface and ideas of the glacier, well, that tells me and you that they have an immediate cause. Like the material is what caused this thing to start melting. And because of that, we get stuff like sometimes glaciers don't have their own melt water washes their moraine away. So that's a cause and effect relationship. And as you can see, we've already done the first part. And it takes up a big part, so you just do it for 4 different subjects. Plate tectonics, weathering, and volcanoes. When you're done, remember, hit turn in. You're going to hit turn in. We're going to get done with that, and then we'll have our exit ticket. Your exit ticket will be right down here. I'll need you to finish that as well. So please keep in mind as we do this that you are completing and finishing up your work for today. I'm not gone. I'm just away for a little bit, and then I'll be right back, okay? I'll talk to you guys later. Have a wonderful day, and I'll see you on Monday. Bye. And excuse my boomer behavior, but I have to get out of here. I'm not actually a boomer, but I just act like one on TV.